Class, welcome back to Stanford Code In Place. This is week 2, and I'm going to be showing you the Checkerboard Karel problem. Now, first of all, I want to point out the Checkerboard Karel problem is an advanced problem. It is not required for your success in this class. However, it's a new problem that I really liked. It's introduced this year, and I really liked it. And I wanted to show you how I approached solving it, even if you don't code it. I think seeing the approach will reinforce some of the things that were important to learn this week and will help you as we go forward. First, I'll just show you what the problem is about. So we're going to draw this checkerboard here, and it's similar to some of the other problems you've seen in lecture and during the week. In fact, I'm going to go take a look right now at a problem that we did in section called spread beepers. And in this problem, what we do is we take a beeper out of the pile and then we pick it up and we spread it out farther, okay? And we're going to keep on spreading. And notice here when it goes to 0, it restores it and puts it back. There are a few things that I want you to think about from this problem as we work on the checkerboard problem. So one thing I want you to think about is the problem decomposition. How did we go about solving this? As a professional programmer, I worked on Microsoft Excel. I will definitely tell you that top-down design and problem decomposition is an important thing to know and to learn, and we use it all the time. At the very highest level, this problem is about setting up Karel to succeed with loops, doing the actual spreading of the beepers, and then cleaning up. And so ideally, you want your main function to be as simple as this. Then we go start delving down deeper into each of these levels. So what was involved in setting up Karel? Well, we needed to move Karel onto this first beeper here, because that is where, if we have a loop, we need to always be checking this pile of beepers until we get from 4 down to 3, then 2, then to 1. And the only way that we have to tell to stop is not at 1, but we have to stop at 0. There it stopped, and then it did its reset. So that's what setup is about. And then cleanup is similarly straightforward. When we're done with this drawing, we need to move Karel back to the beginning. Okay? And then what is spread about? Spread contains nested loops, which are a very important concept, one which almost every student struggles with a little bit. So if you're struggling, don't feel like this is unusual or you're not doing well. Nested loops is something that we teach in all computer science classes, and it takes a while. So in this case, what are the nested loops? Well, I already told you that there's an outer loop here looking at whether there are beepers present on this pile of beepers here. We need to go 4, 3, 2, 1, and then 0. That's the only time that we can stop because that's the only test we have. If we had a test for if there was 1 beeper left, the code would be better because we wouldn't have to take it away and then put it back later. But we don't. So we are going to check for whether there's a beeper present, and if there isn't, then we need to stop. But we've already done too much, and so we need to actually put the beeper back. And so we need to restore that beeper and then move the position back. But this outer loop, every time that we have a beeper here, once we get that beeper, what do? Well, we actually have another loop because we need to go walk down this list and find where is the next place here. So it's going to take from 3 beepers to 2 beepers. It's going to have to walk down until it finds a place where there are no beepers available. Well, guess what? That's a loop. So there's an inner loop. Inside this outer loop, there's an inner loop called spread beeper. And what spread beeper does is it's going to have to execute a loop walking down to find the free position, put the beeper there, and then go back to reset ourselves into that position. So that's a second thing that I want. The first thing was the idea that your main loop is very simple and has just a few steps in it. Second thing was we got nested loops. Okay. The third thing is that this idea of resetting the position to make sure that your loop is ready to execute. It's always important when you have a loop. There's actually, I think of it as 3 different things that you need to figure out for a loop. One is how are you going to stop this loop? Okay. So in the outer loop, it was when the beepers got to 0, there were no beepers. In the inner loop, it's when we don't find any beepers walking down the loop. Okay. So we have to know what's to stop the loop. You have to figure out what are you going to do in that loop. So in the inner loop, it was walking down this list and then putting the beeper there. In the outer loop, it was just you decrement the beeper, and then you call the inner loop to spread it out. And the third thing I think of is what do you want to include and exclude in each of these loops. And I won't go into the details here, but we had to figure out what was necessary at each step. The one point I want to bring up is this idea that we had to reset our position. Let me run it again. We had to reset the position. After every loop, we need to be back on this pile of beepers, facing the same direction. If we don't do that, then the loop isn't going to be able to repeat. So, for example, if I tried to start the loop here at the beginning, there would be no beepers present, and the whole thing would stop before we're done. So we need to move ourselves to this pile of beepers. All right. So now let's go try to apply those lessons to the new problem, checkerboard. So if you haven't watched Chris's lecture about Roomba Carol, I would suggest you do it because it's a great demonstration of trying to walk through all the different ways to solve the problem. And you do need to really figure out how you're going to solve this problem fairly early in the process. But what I mean by that is, in this case, there are a couple different ways you can approach this problem. You can imagine that Carol walks one row at a time, and then goes to the next row, and then to the next row. Or you could imagine that Carol walks down a row, and then comes back, and then comes up, and then goes down and back, goes up, goes down and back. You can imagine doing all of those things, but turned 90 degrees. So instead of drawing a row, we'll draw a column at a time. And then we can come back. A column and then come back. Or we could do a column and come back. A column and come back. Column and come back. So there's also a third way of doing this, which is you could even do it on diagonals, right? Because the diagonals are really what this is about. This is a series of diagonals. So you might start here and draw a diagonal, and then try to come back and draw the next diagonal. But you notice that after you've done this third diagonal, you're not done, actually. Even though it seems like you're done because you'll hit a wall, you need to come back and do these guys. And so for your setup, you might need to go and start at the farthest diagonal. Okay, start there, and then work your way back doing diagonals. So the way that I actually chose to run it, I'll show you right now how I ran my program. I chose to do it actually going columns. And I chose it to do the most challenging way of columns, which is I don't come back to the same row I started in. I actually, I'll do it and I'll slow it down for you. So it is probably more straightforward and consistent to come back to this starting position. I probably should have come down here and then moved to the next row and moved on. I did a more challenging way, which I don't recommend students do, but I did a more challenging way, which saves in runtime by actually turning around and then coming back in the opposite direction. It makes it more challenging for a couple of reasons, because you no longer have the same directions that you're turning. It depends on which end you're at, so it makes it more complex, but it does speed up the actual execution of it. But I just wanted to show you another way of executing the program. I've really enjoyed seeing on the forums different student solutions. Most all of them will go row by row. I don't think I saw anyone actually going columns by columns. I actually started doing it row by rows, and then I switched. And the reason why is because before I got very far, I looked at the different worlds here. So we got this 3x5 world, which isn't a whole lot different than the other one. It's just that we have a beeper at the far right. But this was the one that convinced me I needed to do a column at a time, right? Because boom, you do one column and you're done. So that's why I decided to do it a column at a time. But I'm actually going to walk through building this code the way that most students have approached it. I'm going to do it in columns just because I'm familiar with doing it in columns. But I am going to do it the way that most students would approach it, which is to return yourself to the same position each place. And I'm going to walk you through. I'm not going to show I'm not going to give you the code, okay? Non-spoiler alert, okay? You're not going to walk away from this having code, but you will walk away with it understanding what is the process, which is really the most important thing you should take away from this, so that you can apply it to the next program. And I'm going to show you the steps that I took in developing it. And I want you to write the code. That's the most important thing. So I've decided that I'm going to draw one column at a time. And just for flexibility, I'm just going to call it a line, even though it's a column. And so let's start by just doing a function. I'm going to call it a draw line. And I don't actually want to draw the line right now. I just want to have something in place so that I can put it into the larger main code and just make sure that it works. So for now, I'm going to have draw line just move forward until it hits a wall. So assuming that we're facing the right way, we're gonna have to, let me reset Karel here. I'm gonna try having Karel turn left, and then we're gonna have a loop move forward till wall. Okay, so that means while front is clear. I told you I wasn't going to show you any code. I'm going to give you a little bit of code, but this is not the full solution code. This is just enough to show you the thought process. So while front is clear, we're going to move. So let's just try seeing if this will work. So draw line is going to turn left and then move forward. So let's try running that. And so that does work. And let me slow that down because during develop we're going to want to actually see it. Okay, so that drew one line. Okay, now we're also going to need something that is going to reset the position. So I'm going to do a new function here. Let's call it reset loop. And what reset loop will do is it needs to turn around and then move to the opposite end and then move to the next row. Okay, so that I can repeat this, because what I want to do here is I want to have a loop while something draw a line. That's what I want to do. In order to make that repeatable, I need to set up first, am I ready to call draw a line before I get in here? And then second, is draw a line going to set me up to draw the next line? Okay, so I need to move myself in there. And so I'm going to call a function reset loop, but I'm going to hide the code from you because there is some code here I want you to figure out on your own. But I'm going to do it, and then I'll come back and show you. I went ahead and wrote some of that code, and now I'm going to just show you an execution here. So Karel's going to draw this line, which doesn't draw anything right now, and then move to the next place to start. So am I in the right position, direction, etc. to be able to draw a line? I think so. So let's try putting this in a loop now. So I left this while, but what is the while condition that is going to stop? Well, as Karel moves along here, eventually Karel's going to be facing a wall. And when it's facing that wall, that's when we want to stop. So while front is clear again, we want to try doing this draw line and reset loop. So let's try running that and see what happens. And let me speed it up. Okay, so Karel did all of that. Now, notice if I use this stepper up here, which is an important tool to use, notice that Karel stops here, and we actually want to, again, actually draw that line on that last one. So we're actually going to have to, after doing this, we're actually going to have to draw the line again and reset the loop. Except that last time when we reset the loop, we're going to try to step forward. It's going to fail. It's going to fail. So I need to make one modification in my resetting the loop so that it checks to see if there's a wall before it moves forward. But let me do that and come back. Okay, so I've made that change. I'll go ahead and run it again. So this works. Now, before I move on, I want to make an important note. You've heard this thing called the fence post problem. And guess what? You've got a post here, and then you've got the fence, right? You got the post and the fence, post and the fence. And so this is one of these fence post problems. And I was telling people in my section that, believe it or not, they didn't teach this fence post problem when I was in school 30 years ago. It's a good learning tool, but if you don't understand the fence post problem, you don't understand how to identify it, it's okay. Because the old days, we would just, we realized that we call it off by one, and we would then fix it. And just like we fixed it here, But if you can realize that this is a fence post problem, it kind of preps your mind in advance, saying, "Oh yeah, right. Okay, so when I'm done here, I'm off by one. Okay, I'm off by one. How do I fix it?" And in this case, we can put that last one outside the loop. You can solve the fence post problem several ways. You can do it before the loop, and then you actually have to reverse the insides of the loop, or you can do the loop and then do the last one outside the loop. There's lots of different, not a lot, but there's a few different ways. Okay, so this has gotten complicated here, right? So I'm going to replace this now with draw lines. Let's call it draw checkerboard. Okay, so I'm going to put all of this function into another one so that I can keep this code looking clear. Let me just make sure that all works. Again, I'm always running it to make sure that it's still working, all right? So we've got our draw checkerboard. Actually, checkerboard. Now, you may have noticed that we didn't actually draw anything, right? Okay, so now we actually have to figure out how to draw a checkerboard. Okay, so let's go back to the draw line. So right now, draw line is turning left, and then it's just moving forward. So we got to start putting beepers down here, right? So we can go ahead and start saying put beeper. What does that do? Let's just see. Okay, and notice, what do you notice about this up here with it not drawing the last one? Fence post problem. Fence post problem. Okay, so we need to actually put a beeper down at the end. But let's start thinking about the other problem, okay? So the other problem is that, well, it's solid, right? It needs to be every other beeper and not every beeper. Okay, so let me put those solutions in. I'll come back and we'll work on the next problem. So I've hidden the code from you because I want you to do the code. But let me show you how it runs. So what do we see here? It is putting every other beeper. That's good. We see that it's not alternating, so that's something we have to worry about. So we need to figure out, first let's revisit, how did I figure out how to put a beeper in every other place? So there are no variables in Karel. If you had variables, what you would say is, you'd probably set up a Boolean value. Okay, if it's false, then we put a beeper. If it's true, then we move true, then we would just skip the space. But instead we have this ability to store beepers and tell us. So we look at the first space that we're sitting on in the loop, and if there is nothing there, then we will want to probably put a beeper. And if there is something, then we don't want to put a beeper. Now I've actually kind of done it the opposite way right now. So notice this first space has no beeper, and the other ones, and then it alternates from there. So we really need to make sure that this first space has a beeper. So I'm going to have to do a little bit of code to fix that. I'll come right back. Okay, so I fixed it by simply putting a beeper in the first space. My code is smart enough that if there's a beeper, it will skip it. If there is no beeper, if there is a beeper, then okay, I'll just put this. If there isn't a beeper, it'll put one there. Okay. If there's already a beeper, then it'll skip to the next space. All right. So it worked for the first two rows, but it doesn't work for the rest of them. So and how did I figure that out? Like I mentioned, so we can test whether there is a beeper or not. Okay. So and then we need two cases. We need an if and else. If there is a beeper, we should do something. If there isn't a beeper, we should do a different something. So you have to get those two cases straight. Now let's come back to this problem that it's not actually alternating. Okay, it did these first two that way, but then it doesn't alternate. So we have to figure out how do we get it from this first one. So there was a beeper that we put down manually to start this. The second one, we don't have the benefit of that putting the beeper there, which worked out fine because it drew it the opposite. But the third one, it actually needs a beeper there. So let's think, at what point do we know and it's a very limited window. At what point do we know what should go here? Whether should this be a beeper or not a beeper? Should this be a beeper or not a beeper? Well, the point where we know that is actually after we've drawn this and come back, because what do we know here? We know that there's a beeper. So that probably means that the next one is not a beeper. Okay? And then when we go to the next one, if this one is not a beeper, we've drawn this and come back, that probably means the next one should be a beeper. So where does that code live? Well, that code lives as part of drawing this line, but it's not really drawing the line. It's actually what I called reset loop. Okay, because, well, to draw the line here, it's part of what resetting loop has to come back down, and then right here, I'll step through it. Let me step through it here. Let's come back here. So yeah, so reset line is coming down here, right here at this point. That's when we know we've got a beeper, and so this next one will not be a beeper. We go through the loop again, so we've gone through reset line right here at this point again. Now we know there's no beeper, so the next one has a beeper. So just like I was talking about how we drew that line originally, now we've got another if and else. If there is a beeper, we do one thing. Else there is no beeper, we do a different thing. So I'm going to put that code in, and then let's see what happens. So let's see how it runs now. So as you can see, it is now alternating rows. And again, so what I do is when I, this slider, when I'm resetting a row and I come back to the original spot, right here, before I move to the next row, next line, I need to have an if statement. If beeper present, do something. In this case, since I have a beeper present, I'm just going to move. And let me go back to the other one here. In this case, if beeper present, false, skip to the else. So now what I need to do is move and put a beeper. Okay? So two different options. But you notice that there was something wrong at the end. What happened at the very end there? I did the reset. It came back down here. And then it said, once again, if there beeper present, do something else. So we're going to execute the else. Move forward, which I have implemented to check whether I'm going to hit a wall before I actually move forward. And then put a beeper. Well, okay, so it followed the instructions, but now it's put an extra beeper there. So what I really need to do is not just safely move forward, don't move forward. I need to actually say, before I move forward, I need to say, if I'm going to hit a wall, if front is clear, so if front is clear, so I'm not going to hit a wall, then what am I going to do? I'll be able to take a step forward and do whatever I was going to do. But if the front is not clear, then I don't want to take a step forward or put a beeper. Okay, so let me fix that, right? I went ahead and made that change, and now I need to create a cleanup function. And what is that cleanup code going to do? So in this case, the cleanup code, it just needs to turn itself around and get back to the beginning here. So let's see how that runs. So again, I added cleanup code, so now it comes back, and that's it. The code is done. So it all worked. So what are the important parts of this checkerboard problem? Well, number one, there's the high level, how do you break down a problem into steps? So we have three main steps. We have setup Karel, which turned out to be just putting the beeper down. We had drawing the checkerboard, and then we had cleaning up. If I were to do a diagonal, this setup Karel would have been more complicated. I have to go over and figure out where does the last one start. I suppose I should try these other ones here. Let's do the 3x5, and let's do the 3x1. And so I would suggest you always try to have a running program. Make a small change and then get it to run. So what I did first is I tried to drawing one line without even drawing anything, just drawing a line, and I tried making sure that I could set myself up for the next loop so that my outer loop could terminate properly at the end. Okay, so that's the first step I did. Then I went back and I actually filled in, well, what does drawing a line really do? So I made an attempt at drawing the line. I saw what worked, I saw what didn't work, I fixed it up. So then I needed to make sure that it alternated every other line. So I had to look again at using state. If beeper is present, do something. Otherwise, do something else. So then I had alternating ones. Then I noticed that I had a problem at the end. So I needed to be intelligent about at the very end. I didn't want to step forward through a wall. I needed to check and not step forward through the wall or put the last beeper there. And then finally I had to do the cleanup. So this problem involves this high-level breakdown. It involves nested loops. So we got a loop for the columns and then an inner loop doing each row. It could have been the other way. It could have been an inner loop for each row and an outer loop for each column. Could have been diagonals, and so we have an inner loop to draw a diagonal and an outer loop that chooses which diagonal we're going to draw. And we also had fence post problems, right? Remember, fence post problems? So we noticed that when we were off by one, we needed to fix that somehow. Sometimes we would need to put things first. Sometimes we would need to do the operation afterwards. Sometimes you need to do them first, and then you actually need to inverse the order operations inside the middle. So I hope this has been informative. I hope you do try to tackle this problem on your own. I've given you just a tiny bit of code here. That's not enough to do the problem. Most of the code is still has to be written by you. But the entire program is only about 60 lines of code. Okay. And the other thing I didn't show you here is the pre and post conditions, which are actually very important. Because remember all the time I spent about saying, okay, well, it's got to get back down to this row, facing at the bottom of each row, facing right. Okay. So the way that I had done my problem, going down to the end and then coming back, that actually was very complicated for the pre and post conditions, because then there were two pre and post conditions. All right, I could either start at the beginning of the row here, or I could start at the beginning of the row up here. And depending on which end it was at, it became a little bit complicated, but it was still, for every routine, I had pre-conditions. It's either this or this. Post-condition, it's either this or this. And those are important things. All right, so that's all I want to talk about on this problem. So good luck to you. I will mention the midpoint problem. So the midpoint problem is more of an aha solution, meaning it's something that we don't teach in class. It's something that you got to figure out on your own. And for that reason, I don't think it's as important as this problem. There are a little bit of aha moments, in particular, the idea that you have this if beeper is present, do this, else do that. We didn't teach that so much at all, I think, in class. And so that's a bit of an aha moment, but I've already given you that instruction. So hopefully you'll be able to solve this one. Midpoint is another challenge on its own, and there are different, I think there are more ways of approaching the problem. So you can definitely try midpoint after this one, but I hope that some of you will attempt checkerboard. So good luck to you.